Good morning, Prof and Doctor. My name is Paul Wei Chuan from Group 1. Today we would like to present our project IoT with the title of Autonomous Robot Car with my teammate Amzi, Lim, Sai, and Ahmad Daniel.
My name is Sai Dashan Analaki Mohan, matrix number A164476, and I will be talking about the introduction. So, robotics have helped humans in achieving daily activities as they are designed to work in any environment and do work for the human race. However, few studies have made an autonomous robot leading to wholesome potential application for autonomous robots, according to Lam Lung Man. So the first major robot development effort name was Shaky. So it was created in the 1960s as a research study for the Defense Advanced Research Project Agency, which is also known as DARPA. So fully autonomous robots may have the ability to gather information about the environment, such as building a map of indoor buildings. Number two, detect objects of interest, such as people and vehicles. Number three, move waypoints without the aid of human navigation, and work for long periods without human intervention. In general, advances in the field of robotics today began with the development of remote control mechanical processes after the Second World War, and now we are on the verge of Industrial Revolution 4.0 with a smart industrialization team for the future. So looking at the current advances in the field of robotics, it will not take long before we can interact with robots and work all in running daily life. Thank you.
Assalamualaikum, my name is Ahmad Daniel. I will cover 4 problem statement. The first one, what is the application of innovating autonomous robotic car? The second one, development of the communication system between robot and supervisor device. The third last one is how can the movement of a robot can be safely controlled remotely without wire. And the objective for this project is to develop a communication system between robot microcontrollers and computers Internet of Things. And the second one, to develop a control system to control the movement of the robot with secure remotely wireless via IoT, and to study the application of autonomous robotic car.
Hi, I'm Julian. Now I'm going to talk about the applications of Internet of Robotic Things. The first one is manufacturing industrial. The most common IoT applications in smart factory include cooperative robots, robotic painting, welding, assembly, packaging, material removal, parts transfer, and machine tending. Robots can be trained to perform these repetitive tasks so that people can focus on more mentally challenging and creative tasks. The second one is transportation mobility, which include fleet management, telemetry control, geolocation and map mapping, and self-driving car which can perceive its surroundings, identify appropriate navigation paths, as well as obstacles and relevant signage, then move safely with little or no human input. The third one is home living. We have smart home which allow us to remote control appliances, lights, and other devices by using a smartphone through an internet connection. Robotic vacuum cleaner is also a robotic example which allows us to remote control and set the working time. Then it will follow the calculate cleaning routines to do the cleaning stuff and automatically return to its charging port after the job done. The next one is supply chain. We also have smart warehouse which use automated picking robots and automated guide vehicles to complete common warehouse operations that previously performed by humans, such as put away, loading, and stock take. Typical smart agriculture projects include precision farming, livestock monitoring, irrigation management, and automated drones for surveying farms, mapping fields, spraying crops, and more. Robots also can be used for seeding, weed control, spraying and harvesting the crops, which allows farmers to be more efficient. One of the healthcare IoT applications is robotic personal assistance, which can respond to human speech, express emoji, and communicate with people as they are used for help with personal care, socialization, and for training purpose. There are many IoT applications in military. For example, ISR, search and rescue robots, combat support, mine clearance, EOD, and firefighting robots. These robots can help monitor enemy forces, even being designed to handle a broader range of combat tasks. That's all from me. Thank you.
Good morning, my name is Paul, and I will be presenting the methodology part. For the methodology part, we have used some apps and hardware like Blink application, hybrid circuit, robotic car, and ESP32. The motors and battery are used to build up the robotic car and then connected to the hybrid circuit and then to the ESP32. After that, the coding of evaluating and controlling the movement speed of robotic car is done using Arduino IDE and uploaded to the ESP32. Subsequently, a communication system is set to the ESP32 directly to the smartphone using Wi-Fi and Blink app. Finally, we can control the movement of robot car using smartphone through Blink app and Wi-Fi. And the following below is the Arduino code for robotic car, and it will be discussed by my teammates Amzi in the discussion. Thank you.
Assalamualaikum and greetings. My name is Muhammad Amzi bin Muhammad Fauzi with a matrix number of A163072. For this presentation, I will be presenting about the results and discussions of our project. So firstly, using the ESP32 microcontroller, we were able to control the direction of the motor using a H-bridge. The software that we use in our project is Arduino IDE to code the program, and also the Blink application that can be used from our smartphones. So these are the code that have been written inside the Arduino IDE software. First and foremost, we must include the libraries needed to program our microcontroller as stated here. Next, we define the pins connected from H-bridge to ESP32. For example, the right motor speed has been connected to the pin number 2 of ESP32. The right motor direction is connected to the pin number 4 of ESP32. Left motor speed has been connected to the pin number 18 of the ESP32 and also pin 19 for the left motor direction. Because we control the motors via Wi-Fi, the Wi-Fi details need to be stated and the Blink token that we receive via email. These are the variable inputs that we use to program our code, to program our microcontroller. For the move control command, we input the X and Y value, which are the range that were defined earlier, and also the speed. The move control command have a move forward command, move backward, move left, and also move right, and also not moving command. These are the setup that we use. These are the setup command that we use to program our Blink application. The Blink joystick, for the Blink joystick to function properly, we need to connect the Blink joystick via virtual pin V1 as stated inside the setup command on the left side here. So these are the example of our motors moving. As you can see, we can move it forward and also backwards when we move the joystick downwards. Due to the hardware malfunction, we were only able to control one of the motors, which is the left one. Yeah, that is all from me. Thank you.
For conclusion, by using Arduino IDE, we can easily execute the programmable language that have been developed, and Blink software act as a digital input and display, thus we able to control the robot remotely through a device. That's all from us. Thank you.